In 1990, Voyager 1 turned its camera back towards Earth from 6 billion kilometers away, capturing a single pixel of light against the vast dark. That pale blue dot is the only place we know where life exists. But in the last 2 decades, we've found thousands of worlds just like it, and some might be even better suited for life than our own home. You've heard of the habitable zone, that sweet spot where a planet orbits its star at just the right distance for liquid water to exist. But here's the thing, it's not just about being in the right place. It's about whether a planet can actually hold on to its atmosphere, its magnetic field. All the invisible factors that turn a rock into a cradle for life. In 2017, NASA announced 7 Earth-sized planets orbiting a dim red dwarf star called TRAPPIST-1, just 40 light-years away. 3 of them sit squarely in the habitable zone, and astronomers think they might have oceans. But there's a catch. Their star is 2,500 times dimmer than our Sun, and it's incredibly active. Red dwarfs, like TRAPPIST-1, hurl violent solar flares at their planets, blasting them with radiation hundreds of times stronger than anything Earth experiences. Imagine standing on the surface of one of those worlds when a flare hits. Your DNA would unravel in minutes. Yet some researchers think life could still survive if it hides deep underground or underwater. When Kepler 452b was discovered in 2015, headlines called it Earth's cousin. It's about 60% bigger and sits in the habitable zone of a Sun-like star. But follow-up studies suggest it might be a water world, with oceans hundreds of kilometers deep and no land at all. No volcanoes means no carbon cycle, no nutrients recycling, maybe no life as we know it. In 2019, the Hubble Space Telescope detected water vapor in the atmosphere of K2-18b, a planet 8 times Earth's mass orbiting a red dwarf 110 light-years away. It's the first time we found water on a potentially habitable world. But that's not even the strangest part. Some exoplanets might have atmospheres thick enough to make you feel like you're swimming rather than breathing. Most planets in habitable zones around red dwarfs are tidally locked, one side permanently facing their star, the other locked in eternal darkness. Picture it, a twilight ring between fire and ice, where the sun never sets and never rises. Some scientists believe that ring might be the perfect place for life, a narrow band where temperatures stay just right. Our solar system's arrangement isn't random. Jupiter's massive gravity acts like a shield, pulling away comets and asteroids that would otherwise bombard Earth. Without that gas giant guardian, life might never have gained a foothold. So when astronomers find an exoplanet in a system without a Jupiter, they know it's a much more dangerous neighborhood. Earth's magnetic field deflects the solar wind, protecting our atmosphere from being stripped away into space. Mars lost its magnetic field billions of years ago, and most of its atmosphere followed. For an exoplanet to be truly habitable, it needs a liquid iron core spinning fast enough to generate that invisible shield. When astronomers study exoplanet atmospheres, they're looking for a specific fingerprint: carbon dioxide, methane, and oxygen all present at the same time. That combination is a smoking gun. It's exactly what Earth's atmosphere looked like 2 billion years ago when photosynthetic bacteria started pumping out oxygen. Some scientists argue that complex life requires an extraordinary checklist: a large moon to stabilize the axis, a magnetic field, plate tectonics, the right distance from a stable star. By that math, Earth might be 1 in a billion, maybe 1 in a trillion. But then there's the other side of the argument, the one that says the universe is so big that even tiny probabilities still produce millions of inhabited worlds. In 1977, scientists discovered entire ecosystems thriving around hydrothermal vents on the ocean floor, creatures living in total darkness, feeding on chemicals rather than sunlight. These extremophiles completely changed our definition of where life can survive. Here's what nobody tells you. If exoplanet oceans are more common than land, then most habitable worlds might actually be water worlds where life begins without ever seeing a star. Kepler's space telescope stared at a tiny patch of sky for 9 years, And from that single field of view, it discovered over 2,600 confirmed exoplanets. Statistically, that means there are probably 300 million potentially habitable planets in our galaxy alone. 300 million. And we've only looked at a fraction of the sky. Now the James Webb Space Telescope is peering into the atmospheres of those worlds, analyzing starlight that passed through alien skies billions of years ago. In 2023, it detected carbon dioxide on a world called TRAPPIST-1c, a major step toward understanding its atmosphere. Every new observation is like reading a page from a book we never knew existed.